Okay, I think now I start recording. Okay, perfect. All right, so yeah, so this is section 5.2, probability rules. All right, so let me just remind you what we said last week very quickly. What's a probability, right? And how we compute probabilities, right? So we said a probability of an event, it's just a numerical value. It's a number between 0% and 100%. And that number actually describes the likelihood that the event will occur, right? And the way to compute the probability is, so you divide the frequency of the event occurrence by the, by the size of the sample, right? So let me just write down what I said very quickly. So a probability of an event, just to remind you, this is recall. Okay, so a probability of an event A, of an event, that's a number, is a number between, or a numerical value, it's a number between 0. So when I say 0, that's like 0%, and 1, which is 100%, right? Again, percent, guys, you think of the percent as division by, that's actually division by 100, right? So when I say 100%, it means 100 over 100. That's why it's equal to 1. So that describes, it's a number that describes the likelihood of the event occurs. All right, and so as we said, in general, the way to compute the probability, right? So in general, so capital P of A. So again, capital P means, so capital P stands for probability, right? So this is probability. And A, that's the event, right? That's the event A. So probability of the event A. Okay, so that's what I mean by the capital P parenthesis A. That's the probability of the event A. All right, so we said this is just the frequency. That's the frequency. You count how many times the event A occurred, right? The frequency of the event occurrence. And you divide by the size of the sample. All right, and again, just be careful. So it's always, you always have a division when you compute the probability. Is like a number over divided by another number, right? So just keep in mind that the number in the bottom, the denominator, it's always larger than the top. Okay, so the size of the sample, so the bottom, the number in the bottom is always larger than the top, because you want to get a number between 0 and 1, and the only way to get a number between 0 and 1 is that the number in the bottom is larger than the top. Okay. And one more thing, guys. So bottom is always larger than the top, and the top and the bottom, they have the same units. So if like in the frequency is, I don't know, like it's like 500 students, then the size of the sample is also in terms of the number of the students. Okay, so we use the same units for the top and the bottom, right? We use the same units. You cannot just like have like a number of students in the top, and like in the denominator you have like a number of I don't know, number of hours, or different units. Okay, so the top and the bottom have the same units. Okay, so every time you compute the probability, just make sure that the bottom is always larger than the top, and that the top and the bottom, they have the same units. Same units. Anyway, so we had, I think, a couple of examples last week and how to compute the probability, right? I think probably we had like 3 exercises or something, which is very good, I think. Right. All right. Now, section 5.2. So today we're going to discuss 2 probability rules. So first, we're going to discuss multiplication rule. So probability has a multiplication rule, and also probability has addition rule. Okay. All right, so let's start with the multiplication rule. So what do we mean by multiplication rule in the probability? Well, this is when we have like 2 events. So the idea here, or the goal. So we have 2 events, A and B. Not just one, we have 2 events, A and B, right? And the goal here is to compute, so we want to compute probability of A and B. Probability of A and B. So when I say A and B, guys, the probability of the events A and B, it means the occurrence of the event A and the occurrence of the event B, okay? So this is A and B, so it means the occurrence of both events, right? So this is A and B means the occurrence of both events at the same time, of both events, A and B. Okay. All right. Now, to compute this probability of A and B, the probability of the occurrence of A and B at the same time, well, the formula for this is actually it's going to be expressed in terms of multiplication. Okay, so it's it's going to be expressed as the probability of A times probability of B. Okay, but that's not true all the time. Sometimes it's more complicated than that. Okay, so let me explain the 2 cases we have. So that's the first case. So case 1. So in the first case, we have 2 independent events. All right, so first case is when A and B are independent. And I'm going to explain, of course, what do I mean by independent. So A and B are independent events. So what do I mean by independent events? Well, so 2 events are independent. 2 events are independent if the occurrence of one, so if the occurrence or of one event, so occurrence or non-occurrence of one event doesn't change of one event, doesn't change the probability that the other event will occur, okay, of one event doesn't. So the key word here is that it doesn't change the probability that the other event will occur. So, for example, So example one. Example one. So let's say you roll. So let's say you roll a die, which is, by the way, actually die. It's a singular of dice. But anyway, so you roll a die, and let's say A is the event is getting 6. Getting 6 on, let's say, the first die, and B is so you have 2 dice, right? So getting 6 on the first die, and B is the event where you get, let's say, 4 on the second die. Okay. So getting 6 on the first die and getting 4 on the second die, okay, the 2 events are independent. I mean, getting 6 on the first die, it doesn't change, it doesn't change the probability that you're gonna get 4 on the second die. There's no connection. There's no relationship between the 2 events, right? I mean, there's no. I mean, the occurrence of A or non-occurrence of A doesn't really matter. I mean, it's not really connected, or it's not really related to the occurrence or non-occurrence of the event B. Okay, so the 2 events are not related, right? There's no relation between the 2 events. All right. So like in this case, we have 2 independent events, right? Because there's no relation between the 2 events. If you get 6 on the first die, it doesn't really matter, right? Or it doesn't really change the probability that you're going to get 4 on the second die. Okay, so there's no relation between the 2 events, right? So the 2 events here are independent. So the events A and B, the events A and B are independent. There's no relation between the 2 events. Getting 6 on the first die, doesn't really change the probability they're going to get 4 on the second die, right? So the 2 events are independent. Okay. Does this make sense to you guys, that the 2 events here, A and B, are independent? There's no connection between the 2 events? I mean, getting 6 doesn't change the chance to get 4 on the second die, right? There's no connection between the 2 events, right? All right, so that's first example. Second example. So here we have 2 independent events. Now, in the second example, example number 2, let's say you're gonna draw 2 socks. You draw 2 socks at random from let's say from a drawer, and without. So we're gonna draw 2 socks, right? And the thing is, you don't replace the first when you draw the first. So without replacing. So the keyword here, I would say without replacing the first. Without replacing the first one before drawing the second one. Without replacing the first one before drawing the second. Okay, so you draw a first sock, right? But then you don't replace the first sock, okay? And then you draw the second sock, right? Before drawing the second. So you don't replace the first. All right, now let's say we have. So let's say the question is, what's so let's say the event A is, so let's say we have in the drawer, we have, let's say 3 green, 2 blue, and 1 red socks. So we have 3 green, 2 blue, and red, right? Socks. So in total, we have 6 socks, right, in the drawer. So in total, we have 6. We have 6 socks. Anyway, so the event A, let's say, is event A is to draw a green sock the first time. Right? Because you're gonna draw 2 socks. So the first time when you the event A, so that's the event A. Sorry, I forgot the A. Event A is to draw a green sock the first time. The event B is the same thing. Draw a green sock, but the second time, a green sock the second time. All right, so let me make a picture here, guys. So we have these green socks, right? There's a three green socks, right? And 2 blue, 2 blue socks, and then 1 red. Okay. So then, so here the question is: are the events A and B independent or not independent? Okay. So the event A is to draw a green sock the first time. Okay, so event A is to draw a green sock the first time, right? Now, the problem is, so with the event A, so if, let's say, suppose the event A occurred, okay, let's suppose the first time you draw a green sock, right? So if you, so here we're gonna have like 2 cases. So in the case of occurrence of the event A, occurrence of A, which means you draw a green sock, draw a green, right? So if you draw the green sock the first time, how many green socks are left? 2, right? So you're left with 2, with 2 green socks, and then 2 blue, and then 1 red, right? 2 blue, and then 1 red. Now the problem is, if the event A didn't occur, the non-occurrence of A, so what does it mean, non-occurrence of A? It means you didn't draw a green sock. So let's say you draw like a blue sock, right? So if you draw a blue sock, then you are left with a 3, right? Then you are left with 3, non-occurrence of A. So you didn't draw a green sock. So you are left with the 3. And let's say you draw a blue sock, right? So they're left with 1 blue and 1 red, for example. So you see, guys, there's a difference here between the occurrence of the event A and the non-occurrence of A. So in the case of occurrence of A, you are left with 2 green socks. In the case of non-occurrence of A, you are left with 3 green socks. But then the second time in the event B, right, the event B, that's when you draw a green sock the second time. Okay. Now, the probability of the event B, as you can see, the probability of the event B depends on the occurrence of the event A or the non-occurrence of the event A, because in the case of occurrence of A, then you are left with 2 green socks, right? In the case of non-occurrence of A, you're left with 3 green socks. So then, of course, you would have like more probability to draw a green sock the second time if you didn't draw a green sock the first time, right? Because you will be left with 3 green socks. So we have more chance to draw a green sock in the case of non-occurrence of A. Non-occurrence of A means you still have the green socks, right? So there is of course, there is more chance to pick or to draw a green sock the second time if you have 3 left. Now, in the case of the occurrence of A, then you are left only with 2. So there is less chance to draw a green sock the second time if you draw the green sock the first time, right? So what I'm saying here is the event A, the occurrence or the probability of the event A, the probability of the event B depends on the occurrence or non-occurrence of A. Because in the case of occurrence of A, you're left with only 2 green socks. In the case of non-occurrence of A, you're left with 3 green socks, right? So there is a difference because in the case of non-occurrence of A, you have more chance to draw a green sock the second time because you're gonna have like 3 green socks left, right? So what I'm saying is that the probability of the event B, the probability of B depends on occurrence of A. So if A occurred, then you are left with only 2 green socks. Only 2 green socks, right? Depends on the occurrence or the non-occurrence of A, or non-occurrence of A. So if A didn't happen, then you still have like 3 green socks. So we have more chance to draw a green sock the second time, or non-occurrence of A. Non-occurrence of A. So we'd have more 3 green socks in that case. 3 green socks left. 3 green socks left. Right, so then you would have more chance to pick a green sock the second time. So in this case, the events A and B are they are not independent. They depend on each other, right? The probability of the B depends on the probability of A, or it depends on the occurrence or non-occurrence of A. So the events A and B, the events A and B are, or depends, are actually dependent. Or in other words, non-independent, right? So that's what I mean by dependent. They are non-independent. Independent. Okay. Does this make sense to you guys? You see the difference between the two examples? In the first example, when you roll the dice, then like getting 6 in the first or getting 4 in the second, the 2 events are independent because there is no connection, there is no relation between the 2 events, right? Makes sense. It doesn't matter if you get 6 in the first die or you get 1 in the first die for the event B. There's no connection between the 2 events. But now for the example number 2, when you draw like 2 socks from the drawer, and then you're not supposed to replace the first one before drawing the second, right? So the second time it makes difference if you draw a green sock the first time or you didn't draw a green sock the first time, right? Because if you didn't draw the green sock the first time, then you are left with 1 more green sock, right? So it makes difference for the probability of the event B, right? Where you have to draw a green sock the second time, right? So does this make sense to you guys? The 2 examples you see, the when you roll dice is, that there's no connection between the 2 events, but here in the second example, it's clear that if you draw 2 socks, the probability of drawing this green sock the second time depends on if you draw a green sock the first or not, right? All right. So well, we'll do have more examples anyway. So that's the idea here. So now the problem is we have two different formulas, and it depends if the events are independent or or dependent. So if so, the now the formula for probability of A and B, formula one. So if A and B are independent, so if the events A and B are independent, then the probability of A and B, it's actually probability of A times probability of B. Okay. So this is when we have independent events. So the idea here, guys, in multiplication rule, so you see the word and, you see the word and here, right? The and becomes a multiplication. So if you have two events, A and B, and you want to find the probability of A and B, then that will be the product of the two probabilities, the probability of A times the probability of B. So that's the multiplication rule. So the word and, okay, change to a multiplication. Okay. Now, when the two events are dependent, so formula two, or before the formula two, let me just say, so if you have like three independent events, more than two, then we can actually extend this formula to more than two events. So so let's say you have three independent events, right? A, B, and C. So let's say we have, so this formula can be extended to more than two events, to more than two events. So let's say if we have, let's say three independent events, A, B, and C, events A, B, and C. So again, the hypothesis that the events are independent, this is very important. Okay, you need the events to be independent, otherwise it's not true. Then the probability of like A and B and C, so A, B, and C, this is actually probability of A times probability of B times probability of C. Probability of B times probability of C. Okay, etc. Of course, if you have like four independent events, then probability of A and B and C and D, that's probability of A times probability of B times probability of C times probability of D, etc. Okay, so you can extend this formula for more than two events. All right. So let's do an example before the case of dependent events. So let's get back to the example where you roll a die. So example. So let's say A, this is where this is the event where you getting let's say you roll a die. Okay, so let's say A is getting let's say 6 on the first die, and B, this is getting let's say 2 on the second die. Okay, so we said in this case A and B are, of course, A and B. There is no, I mean, there is no relation between the two events. So A and B are independent. Now, let me just ask you guys, what's the probability of A getting 6 on the first die? Of course, the die has you have like 6. I mean, numbers from 1 to 6, right?
So 1 out of 6.
1 out of 6, and then the probability of B getting 2 on the second die. It's just the same thing, right? That's 1 out of 6. Okay. Now, if you want to compute probability to get like 6 on the first die and 2 on the second die, right? So this is getting 6 on the first die and 2 on the second die. So this is, we said, because the events are independent. So this is probability of A times, so multiplication, right? Because the word and times probability of B. So this is just 1 over 6 times 1 over 6, which is of course 1 times 1, that would be 1 over 36. Okay. So just to multiply the probabilities of the two events, right? So it's straightforward, right? It's of course you divide 1 over 36. That's equal to actually 0. So let me just finish here. So in percentage, so this is like 0.027. So if you convert this into percentage, you multiply by 100. That's 2.7%. All right, so this is the case when you have two independent events. Now, when you have two dependent events, okay, so now let's see.
I have a question real quick.
Yes, please.
So it's 1 over 6 for A, for event A and event B, because you can only get, like there's 6 numbers on the dice, right?
Yes. Yep.
So, and then you did what to get the 1 over 36?
Oh yeah, just multiplication, right? This is multiplication. Oops, sorry.
Okay.
This is multiplication. So you multiply two fractions, and so the way to multiply fractions, of course, is just to multiply like straight across. So like, so 1 times 1, that will be 1, and then like 6 times 6, that's 36.
Okay.
So just multiply straight across. Yeah, that's how we got that. Yeah, it's a multiplication, right? This is the cross, I mean the x or the cross here, this is multiplication. Multiplication. A product, multiplication. And actually that's why it's called the multiplication rule, because we multiply the two probabilities. All right. Now.
So you said we multiply, I'm sorry, Professor. So you said we multiply.
Please.
All right, that's how we got the 1 over 36. And then we got 0.27, which you divided?
Yeah, just divide. You using your calculator, you divide, you get 0.027. And then.
But I'm dividing now.
Yeah, did you get the 0.027? Like 2777? But then you need to convert into percentage. And the way to convert into percentage, you need to multiply by 100%. So convert, let me just write it here, convert into percentage. So what you do is you multiply by, so 0.027 multiply by 100%. So like 0.027 times 100, you get the 2.7. And then there is a percentage, and there is a percent.
Yeah, because I'm trying to do it on my calculator. So what do I do?
Just multiply by 100.
Okay.
0.027 multiply by 100, you get 2.7, and that will be the answer for 2.7%. Right. Okay, so this is when you have independent events. Now the second case, which is a little bit, I would say a little bit confusing. This is when we have dependent events. So formula 2. So now suppose that A and B are dependent. A and B are dependent events. Dependent. So events, all right. Then the probability of A and B, the occurrence of the event A and the occurrence of the event B, all right. Well, this is equal to the probability of the event A, which is, like in the first formula, right? Times, so multiply it again, probability of the event B, okay? And now I'm gonna introduce some notation. So the probability of the event B, and there's this bar. Bar means given A. So so let me just explain here. This probability of B, and then there's this line A. This is probability of B given probability of B given A. So here, given A, sorry, given A, not B, given A, given A, given. So given A. So what do I mean by given A? So here, when I say given A, I mean that you suppose that A occurred. So here, given A means that A occurred. So you suppose the occurrence of the event A. So A is a fact. We know that A happened. Okay, A occurred. So you suppose the occurrence of A. Suppose the occurrence of A. Of A. So that's what I mean by given A. You suppose that A occurred, A happened, A took a place, right? So that's what I mean by this probability of B, and then there's this bar or line A, okay? That's a given. So this bar here means given, given. Probability of B given A. Right? So let's do an example. Let's come back to the example with the socks, right? We have this 6 socks from in the drawer. So let's do that example. So example. So again, let's just remind you, we have like 3 green socks. Oh, by the way, guys, I don't see the chat. Sorry. Because I'm using my iPad, so I don't see the chat. Is there any question here? Jasmine, oh, you're saying you're here. Thank you. I got you. Thank you. Yeah, I'm gonna go back to the board. All right. So yeah, so we have the 3 green socks plus let me just 3 green plus 2 blue and 1 red socks. Okay, so we said A is I guess I need to mute someone. Sorry about that. Okay. All right. So A is, this is the event A. So the event A. So we're gonna draw 2 socks. We draw 2 socks without, and as I said, this is the key word here, without replacing the first one. You don't replace the first, without replacing the first. Okay. All right, so the event A is to draw, so we're gonna draw 2 socks, right? So the event A, that's when you draw a green sock the first time, a green sock the first time. the B, you draw a green sock a second time. Okay. All right, so let me ask you this, guys. What's the probability of the event A?
There's 6, right?
We have 6, yes.
Okay.
That's the
So
size, yes. That's the size of the sample. So in total, we have, remember probability, right? The probability is supposed to be like the frequency. So the frequency, like you count how many, you count like the event occurrence, and the bottom, that's like the size of the sample. So yes, so as Kayla said, we have
So
6
2.
socks, right? That's like the sample size of the sample. We have 6 socks, right? Now, how many? So you wanna draw a green sock, right? So frequency, you count how many green socks, right?
1. You're gonna draw 1, right?
Yeah, but you count how many? How many?
3.
3. So we have 3 socks out of 3 green socks out of 6. So the frequency of the event is 3. Okay, because you count how many, you want to draw a green sock, but you have like 3 chances. You have like 3 different green socks, right? Out of 6. So we have 3 chances out of 6 to draw a green sock. So for the frequency, that would be 3. So the probability of the event A, this is the 3 green socks. You count how many green socks, right? That's the frequency of your event. So that's the 3/6. The size of the sample, in total, we have 6 socks. So that's half. Oh, I mean, 3/6, divide 3/6, that's 0.5. And if you want to convert this into percentage, you multiply by 100, multiply.
Professor, how you divide the fraction?
No, just use a calculator. Just use your calculator. Just divide 3 by 6. Okay, just divide. I mean, you don't have to. Don't bother yourself. I mean, you don't do it like by hand.
I'm sorry, Professor. You
Yes.
just enter the, you put first the 3 in the calculator, divide by the numbers 6, and then you're gonna see the 0.5.
Yeah, you're gonna
And
see the
then you multiply
0.5.
that by times 100, and
Yep.
then you see the 50%.
Yep, absolutely. Absolutely.
Thank
That's
you
very
for
good.
that.
Yes. Multiply by 100. So 0.5 multiplied by 100, that's 50, and percent. You have 0%, 50%. All right. Now, all right. So now we need to think a little bit about the probability of. So B. What's B given A? So this is, as I said, this means given A. Given A means the occurrence of the event A. So okay, that you draw a green sock the first time. Okay, so we know it's given. We know that we draw a green sock the first time. It's given. It's a fact, right? It's a fact. Given A, it means that A now it's a fact. You know that we draw a green sock the first time. Okay, that's what I mean by given. It's a fact now. All right. So if you draw a green sock the first time, right? So let me just here. So we have this 1, 2, so 3 green socks. We have 2 blue and 1 red, right? Now, we know that we draw a green sock the first time. So we're gonna just erase one green point here. All right, now what's the probability probability of B given A? So probability of B, again, it's to draw a green sock, right? This is the second time. So what will be the probability now to draw a green sock the second time?
2/6. I mean,
Well,
2/2.
Nope.
I mean, 2/3 because there's 3.
Nope.
Oh no,
Nope.
I don't know.
Nope.
Never mind.
No, but no, keep trying. I mean, so you draw, you have 6 socks, right? You draw one. How many left?
5.
5, right? And how many green socks out of 5?
There's 2.
2. So only 2 left. So then the answer would be
2.
2
2 on the top.
divided. Yes, and divided
By 5.
by 5. Absolutely, that's the answer. Right. So you draw a green sock the first time. So then you are left with only 2 green socks. But then, of course, the number of socks now it's 5 because you are not supposed to replace without replacing the first, right? You don't replace the first. So if you draw a sock the first time, then you are left with 5. Right? Without, that's what I mean by without replacing the first. So you don't replace the first. So then you are left with 5. So the size of the sample now it's not 6. Now it's 5. And of course, if A occurred, if you know for a fact that you draw a green sock the first time, then you are left with only 2. So that's 2 out of 5. Okay, so that's so 2. That's frequency. That's the number of green socks. You count how many green socks left, and then this is of course the size of the sample. I'm gonna just erase the points here. So that's the 2/5. So that's 5 will be now the size of the sample. Because we draw a sock the first time, so we have only 5 left. So yeah, so that's 2/5, and of course 2/5. That's 0.4, right? Convert to percentage, multiply by 100. 0.4 multiplied by 100. That's 40, and you have your percent. Okay. Now I can compute. So I have my probability of A to draw a green sock the first time. We said it's 50%. Now probability of B given A. B is to draw a green sock the second time, given the fact that we draw a green sock the first time. That's 2/5. So now I can compute. So the answer. So then probability of A and B. Again, what's the probability of A and B? Well, it means you draw a green sock the first time and you draw a green sock the second time. So this A and B means draw a green sock the first and not just the first time, but also the second. Of course, without replacing the first. So this is because we said the 2 events are dependent. A and B are dependent. Are dependent. So then this is actually, we said the formula is the following. So it's probability of A times, so we need to multiply by the probability of B given A. So just be careful here, guys. This probability of B given A, it's not probability of B, okay? It's not probability of B. It's completely different. Okay, probability of B given A. So you need to take into account that A happened. A took a place, right? So A is a fact. You know that you draw a green sock the first time. So you need to measure the consequence of drawing a green sock of the first time, right? So then you are left with 5, right? But then, 5 socks in total, but then we are left with only 2 green socks, right? Because you know that you draw a green sock the first time. Okay, so just be careful. There is a huge difference between probability of B and probability of B given A. Given A, again, means that A happened. You know for a fact that A happened. All right, all right, so let's compute this thing. So we said probability of A to draw a green sock the first time. It's easy. There are green socks out of 6, and we said that's 50%. So it's 50%. Okay, times, or let's instead of percent, I'm gonna just use the decimals, or easier, I guess. So probability of A, we said it's 0.5. It's 0.5 times multiplication. The probability of B given A, we said it's 2/5, which is 0.4. So I'm gonna just write down here 0.4. So 0.5 times 0.4, right? Just use your calculator. 0.5 times 0.4, that's equal to 0.02. Okay, so 0.02. Okay, and so that will be equal to, I convert this into percentage, that will be 20%. Right, multiplied by 100, 0.2, that's 20%. All right, so again, probability of A, we said it's 0.5 times probability of B given A, we said it's 0.4. Right, so we multiply, you get 0.2, and then you will convert to percentage into percentage. Any questions so far, guys? We're gonna do, of course, more examples. Let me give you an exercise then. Exercise. You can think of, so you can think of this formula. Right, exercise. It's very similar to this one. All right, so in this exercise, you're gonna draw 2 cameras. Okay, you're gonna draw. So we have, let's say, so let's say we have 100. We have 100 cameras. Okay. And there are, let's say, there are 10 defective. There are 10 defective cameras out of the 100. Okay. So again, in total, we have 100 cameras, and out of the 100, there are 10 defective cameras. All right, so we're gonna draw. So we're gonna draw 2 cameras. So the question is, so A. So we're gonna draw two cameras. So we draw 2 cameras without replacing the first. Without replacing the first. All right, so now let's say A is to draw a defective camera the first time. Draw a defective camera the first time, and B is to draw again a defective camera the second time. Defective camera the second time. All right, so the question is find probability of A and B. So we find the probability that you draw 2 defective cameras, right? The first and the second time. So find the probability of A and B. Again, A and B here means you're gonna draw 2 defective cameras the first and the second time. 2 defective cameras the first and the second time. First and the second time. All right, guys, I'm gonna give you a couple of minutes to think about this. We have 100 cameras. Out of the 100, we have 10 defective cameras, and we're gonna draw 2 cameras, right? So we are looking for the, without replacing the first. So we are looking for the probability to draw 2 defective cameras, right? A defective camera the first time, and also defective camera the second time. I'm sorry because I don't see the chat, so I need to check if there are any questions in the chat. Okay, no questions in the chat. Yeah, so I guess we are not. I don't think we're gonna finish this section today, but probably gonna finish it tomorrow. So this section is included in the test. We're gonna finish it probably tomorrow, and then, as I said, Wednesday we're probably gonna start a new chapter in chapter 6, and that's not included in the test. So yeah.
Professor,
Yeah, please.
please let me know if I have this right. So
Mhm.
I have 1/100
What's that?
for
What's
the
that?
probability of A. I put the chance of it is 1/100.
So A is to draw a defective camera, right? So
Yep.
how many defective cameras
Oh, 10.
there? 10. So it's not one, right? You have 10 chances, or like
Also, it's 10
right?
out of 100.
10 out of 100, yeah.
And then would the other one be 9/99?
Yes. Over. Yes, 9/99. That's very good. Yeah. That's
And
the
then
idea.
after that, I'm not putting it in the calculator the right way. I need to slowly write down the steps how to do the fraction thing.
Yeah, and then you need to multiply. Yeah, the two fractions. I mean the two decimals. Yeah.
So when I like say if I wasn't using the calculator, I would do the fraction.
No, you're supposed to use. I mean, this is probably statistics, so it's you're supposed to use.
Tell me one more time how to type it in. 'Cause when I typed it in, mine said sync errors, like it didn't exist.
Really?
I probably did it wrong. I had to have done it wrong.
That's weird.
What I'm putting, because I have to do the multiplication of the
divide first. I mean, you can just do the divisions like separately, like the 10/100, and then the 9/99.
Okay.
Right, and then just write down the answers, and then you can multiply the two decimals.
Okay.
Probably that would be easier, I guess. So
I have 10/100 is 0.1.
Yes,
And I
very good.
have 9 by 100 is 0.9.
No, wait. We said it's not.
Oh, I mean 99. That's my
99, yeah.
mistake. That's my mistake.
No problem.
So 9/99.
Yeah.
0.09090.
Now just take the first two decimals. I mean, first two decimals. That's enough. So 0.09, let's say.
Okay. And then I'm lost.
No, but then you multiply, right? Because we said,
Okay.
remember we said we multiply here, right? We need to multiply, right? There's a multiplication here. So we multiply the two decimals.
I have 0.09.
0.009.
Yeah, I'm sorry.
Yes.
0.009.
That's correct. That's the answer. I mean, then you're supposed to convert into percentage. So then you need to multiply by 100.
Convert to percentage, multiply
By 100.
by 100. So I do 0.009 times
Mhm.
100.
Yep.
Okay, I have 0.9.
Yep, and that's the answer. 0.9%. That's the answer. That's the final answer. Yes.
Oh, okay, so this is, okay, now it makes sense to me. So after you do, the chances, the probability of whichever amount of events you have, then you have to do division by 100. And then after you do division by 100, then you have to do, with those answers, that's what you multiply.
Yep.
And then after that answer you get from you multiply, then you do multiplication by 100.
Yeah, to convert into percentage. Yes.
Okay, all right, I got it.
That's very good. Yeah, that's exactly the answer. So I mean, yeah. So let me just check the chat if there are any question in the chat. Okay. Yeah, guys. So so let's start with the probability of A. Right. So to draw probability of A. So this is the probability to draw a defective camera the first time. So the thing is, again, the frequency, you count how many, so we are interested in defective cameras, right? So you count how many defective cameras we have, right? We have 10. So there are like 10 chances out of 100 to draw a defective camera the first time. So the probability of A, it's 10 over 100. Okay. And as Kayla said, so 10 over 100, that's 0.1, which is 10%. If you convert into percentage, multiply by 100, that's 10%. That's 10. Now, probability of B given A, right? Because the thing is, A and B are two dependent events, right? So this is supposed to be probability of A times probability of B given A. So we need to find probability of B given A. So again, given A, it means that we know for a fact that we draw a defective camera the first time. Okay, so we know that we draw a defective camera the first time. A defective camera, sorry. Camera the first time. All right. So if you draw the defective camera the first time, first the size of the sample. So how many cameras left in total? Well, if you have 100 the first time and you draw one, of course, then you are left with 99. So the size of the sample, we are left with 99 cameras in total. Now, out of the 99, how many are defective, right? Because you want to draw again a defective camera, right? So if you draw a defective camera the first time, then you're left with 9. So here it's 9 in the top. That's the number of defective, the remaining defective cameras, right? So it's 9 over 99, which is, okay, that's it. So this is 0.09. Okay, which is, this is 9%. Right? So we got probability of A, we got probability of B given A. So then for the final answer for probability of A and B, you need to multiply the two answers. So the final answer, so probability of A and B, so probability to draw a defective camera the first and the second time, it's probability of A to draw a defective camera the first time times the probability to draw a defective camera the second time, given that we draw a defective camera the first time. So that's probability of A, that's a 0.1. So it's 0.1 times multiplication, right, by probability of B given A, that's 0.09. So times 0.09. You multiply the two decimals, right? That's 0.009, 2 zeros after the decimal point, and convert to percentage times 100, right? So that's equal to 0.9%. Right? Any question, guys? So let's do one more exercise. So let me just say, guys, so this is a multiplication rule, right? So again, this multiplication rule, there are like two cases. The first case when the two events are independent. So you just multiply the probability of A by the probability of B, right? This is the first case, formula number one. This is when you when you roll a die, then you just multiply the probability of A by the probability of B. Now the second case, this is when you have two dependent events, right? So then the formula would be probability of A and B. It's probability of A times probability of B given A. All right, so this is like for multiplication rule. So tomorrow we will discuss the addition rule. And in the addition rule, instead of and, we're gonna have the word or, probability of A or B. But so we have like 10 minutes. Let's do another exercise, okay?
Can I ask you a question real quick?
Yes, please.
So the top, the numerator, it goes down after the occurrence of A. And the same thing for the denominator. Once A occurs, that's always going to go down too.
Yep, yeah, both.
Okay.
Yeah, like in general, yes. Yeah, that's a good point. Yeah, both they go down. Yeah, in general, yes. Yeah, very good. All right. So in the last, I don't know, 10 minutes or so, let's do another exercise. And then, as I said, tomorrow we'll do the addition rule. So exercise 2. All right. So, so let's say we have 100 students. Okay. And so 100 students, and then and we have like, so let me see here. Yeah. So we have 40 male students. And so in total we have 100. Now we have 40 male students, and then 60 female students, and 60 female students. Okay. So the total, of course, is 100. All right. Now we're gonna draw. So A. So we're gonna pick. We're gonna pick 2 random students out of the 100, of course. So we pick 2 random students without replacing the first one. Right now, let's say so for first question 1. So A is, so the event, so you're gonna pick a female student the first time. Okay. B, you pick, let's say again, a female student second time. Okay, so the question is, what's the probability of A and B? So probability that you pick a female student the first time and a female student the second time, right? 2, second question. Let's say A, you pick a female student the first time, female student. Then B, you pick male student the second time. Okay, so what's probability of A and B? So here, of course, A and B, I mean to pick a female student first and then pick a male student the second time, all right? So we have, of course, 2 different situations, right? So the first situation, you pick a female the first and the second time. Second situation, you pick a female student first time, but then you pick a male student the second time, all right? So I'm gonna give you a couple of minutes. How many minutes we have? Okay, yeah, still have 5 minutes, all right.
Can I go over mine with you?
Yeah, sure, please.
I just want to make sure my first, I
Yeah.
have 60 over 100,
60 over 100, yes.
and then I had 59
Mhm.
over 99. Oh, no,
Yeah.
that was, yeah,
Yeah,
59
you're right.
over 99.
That's right. That's right.
Okay. And then that's as far as I went so far.
Okay.
So then I'm gonna do my division.
Yes, you do your division.
Division by 100. So I do 60 over 100, and I do 59 over 100.
No,
and then-
no, wait. No. It's
I mean, oh no, 59 over 99, excuse me.
Sure.
Okay, all right, let me start doing that.
I'm gonna check the chat because I don't see it. Okay, no questions in the chat, right? Please, guys. I mean, if you have the answer for number 1, you can write down your answer in the chat. I can I can check if your answer is correct or not.
Professor, is it
Yes.
0.0119?
Yes, remember for
Okay.
number 1.
Yeah. All right, I gotta do 2 now.
Mhm.
Professor, so would it be for the male? It'd be 40 over 100?
So
Well, first off, pick a female the first time, so
yeah, first time we started with that. Yeah, we start with A.
it would be 60 again, right?
Yeah, again 60 over
60
100.
over 100. And then the male would be 40 over 100, 40. Oh, 40 over 99.
Nah, yep, that's the thing. 40 over 99. Yep.
Okay,
Because you are not supposed to replace the first student, so you're left with
Yes.
99 students. Yeah, that's the idea.
okay.
Yeah, so yeah, I'm gonna just write down the answers, guys, because I have like two minutes. So let me just say, like, for number 1, yeah, as Kayla said, so it's so probability of A and B. So we said we have 2 dependent events, so that's probability of A times probability of B given A. Now, probability of A to pick a female first time, so we have a 60 female, so that's 60 over 100 students in total, right? Times, now for B, given A. So if you pick a female the first time, then you are left with 59, right? 59 females the second time. And in total, of course, because you are not supposed to replace the first student, so we are left with 99. Okay, so it's 60 over 100 times 59 over 99. So what we are supposed to do, guys, we are supposed to divide 60 by 100. So 60 over 100, that's 0.6. Okay, and then you're supposed to divide 59, sorry, by 99. So that will be equal to 0.59. Okay, but then you multiply by 0.6. Okay, so multiply by 0.6, that will be equal to actually 0.357. So convert to percentage, that's actually 35%. So the answer for number one, it's actually 35%. For number two, just in 30 seconds, guys. So for number two, so again, this is just the same formula, A and B, probability of A and B, probability of A to pick a female student the first time, plus probability to pick a male student the second time, given that we picked the female the first time. So as Kayla said, over A doesn't change, it's just the same thing. It's 60 over 100. But now for male students, we have 40, right, over, but then because we are not supposed to replace the first student, right? So there we are left with 99. So again, 60 over 100, that's 0.6 times the 40 over 99. So that will be equal to 0.40, 0.4. So multiplied by 0.6. So that will be equal to 0.24. Okay, convert to percentage times 100%, that's 24%. All right.
Professor, you know how you
Yes.
use those first two decimals, 0.4? Because I had gotten 0.40404.
Yeah, I mean, you can use that number.
Okay.
That's fine. You can use that number and multiply it by 0.6. That's fine. I mean, if your answer is very close to the right answer, it's fine. I mean, I don't really, if you get like 0.23 or 0.25, it's just the same thing. I mean, that's not a problem. 0.40, that's the same thing as 0.4 actually. 0.40, that's the same thing as 0.4. You can just ignore the 0 after 4. It's equal. But yeah, I mean, even if you use the whole number like the 0.4040, etc., multiply by 0.6, I mean, gonna get something which is very close to 0.24 anyway.
Okay.
Okay. Any other question, guys? Let me see the chat. All right. Right. Well, I guess that's it for today. So thank you for listening. And so I hope I'm gonna see you. I'm gonna just stop sharing. Yeah. So I hope I'm gonna see you tomorrow, guys. All right. Thank you for listening, everyone, and take care. See you
Hey,
tomorrow.
Professor, I have a
Bye,
question.
Professor.
Bye. Thank you, everyone.
I just have a question about the homework, Professor.
Yeah, sure. I'm gonna just stop recording. Where's the recording? Sorry.
Okay.
Stop recording.